All right, hey guys. So everybody has a copy of Exploration 011, a common cube conundrum. But I want to point out a couple of things. At the top, above the little box around it, it says something about the second sentence. These 3 explorations of lesson 01 are designed to be accessible to you no matter what your mathematics background is at this point. All right? Okay. Also, underneath the cube in the picture, there's an explanation of what you're going to do. But I also want to point out that on your picture, it's black and white. And the darkened part is actually orange on the color copy. So you might want to highlight that area so you understand what they're talking about. All right, so y'all work together and read that bottom part and start trying to figure this out.
So you want to read it out loud?
Sure. Suppose one desired to move along the surface of the cube from the top far corner, point A, to the near bottom corner, point B. Would the dark line path marked in the picture be the shortest route from point A to point B? If you agree, justify your answer. If you do not agree, describe the shortest path and justify your answer. Is the shortest path solution that you have chosen unique?
When I look at this, I immediately feel like we're going to have to do something with the Pythagorean theorem.
Oh,
Okay. So I guess we should probably start by figuring out, do we think our highlighted one is the shortest? Is yes or no?
At first I said no because I was like, a diagonal is going to be longer.
mm-hmm.
But I either have to do the diagonal here or the diagonal here. And then do a straight. So it's like, it feels like I don't know how.
And then that's the same distance.
Oh wait, if
as
you
the
do straight,
cube.
straight, straight.
I think the diagonal is always shorter, but to me the question is it shorter to do diagonal straight or straight diagonal?
It should be the same.
It should be the same, right? If we just assign a value to the side lengths of the cube.
It is a cube.
Should we
It
just call
looks
it,
shorter.
should we just call it X?
Okay.
Or 1. I mean, really, it doesn't. If we're just saying what's big, what's longer, what's shorter, we could use numbers, right?
We could.
Okay, let's use numbers. What number you want?
1. It's easier.
Okay.
Okay, but I have a question though. Are we restricted to just traveling along edges and pure diagonals?
Mm.
Well, if you did, like, she's talking about Pythagorean theorem, but wouldn't that go through the center of it? And
Well,
would
I
have
mean,
to be on
But
the
I
surface?
think
No, 'cause you would
what
be
Jen
like-
is saying is, could you do this and this?
Like you go inside.
No, not in the interior, but I mean,
On the surface.
staying on the surface.
So if we were to lay this out flat, like unfold it,
Mm-hmm.
Okay.
wouldn't that work to do what you were saying right there?
I mean, if you're traveling on the surface, you could travel however you want.
Right.
Okay, what are you saying? Unfold it? Would you
Yeah,
say unfold
if
it?
we
You say unfold it?
I don't know.
Should we draw it?
You draw it out and like,
Okay.
got some scissors.
Let's draw a cube net.
Oh, that's been a hot minute.
It's like a X.
Okay.
Like a little T.
Mm-hmm.
Oh, I ran out of room. It looks like that.
Okay.
Oh, it does have an extra one, doesn't it? You're
Uh-huh.
right.
And all these are 1.
2, 3, 4.
So on our
Okay, so
diagram,
A would be-
yeah.
Well, A is here and here, right?
It depends on how you're looking at it.
Mhm.
I'm just gonna pick
Can't we
one to
just
be.
take any corner?
I'm just gonna pick one to be A and try to figure it out.
Okay. So then I'm gonna say this is A.
So if this one is this one, and this one could be this one.
Oh, so you're thinking of your cube
Mhm.
opening down. I'm picturing my cube opening like or closing like
That's
this.
Yeah, it kind of just
Mhm.
depends on how you wanna.
Like if that was
I
the
like
top
how
of
you
the
guys are doing it.
cube, and then you go across the edge and then diagonal.
Yeah, but that's the same
But
distance.
could
as
you
this
just go across anywhere? What I do notice though, if we make that one, right, then it's a special right triangle. On one root.
So this would be 1, 2, 3. 'Cause
So it'd be 1 plus root 2.
Mm-hmm.
Just looks much bigger because of the perspective.
Mm-hmm. I do think if this is the shortest, and I'm not sure yet, if it was the shortest, I would say it is not unique. Because
Yeah,
like
you can go
Elizabeth said,
different.
you could do the same.
With the same
Mhm.
leaves.
Mm-hmm.
Okay, so I did my nets and I kind of drew where the original path was.
Mm-hmm.
So on a flat surface, that's definitely not looking like the shortest route between 2 points.
That's true, because a straight line is the shortest.
Yeah, so it'd be like. That one right there.
Which actually, does that make an even bigger right triangle?
It does. Well,
I'm confused about it being a right triangle
we
anymore.
can
Like
figure it
here, I
out.
see it as a right triangle, but here, like
Oh, we're
if we were
saying if you
doing
go from
3
here to
different
here
things-
and then make, she's saying make
Yeah.
this your right triangle.
So we could figure out what this distance is
Oh.
to see if it's shorter.
There
Because
we go,
now that's
using the
2.
numbers.
Yeah,
Okay.
so now,
So we know it's 2 and 1 sides,
mhm,
right?
yeah. So then, root 5?
I'm seeing that too. And then root 2 is what, 1.4 or something, plus 1 is 2 point something. And then root 5 is.
And root 5 is 2 point something. And it's gonna be closer to, it's gonna be closer to, 2 than to 3.
Okay.
So, the first one was 1 plus root 2. And the second one's root 5. So 1 plus root 2 is going to be 1 plus 1.4. Is that what it is? Okay. So about 2.4, and then this one, I think this one's gonna be less than 2.4.
Let me try it. I
Because
Yeah.
it's closer to
Well,
2
and also-
than it is
To
to
3, and
yeah.
much closer.
visually, geometrically. I mean, just visually, it's shorter.
Mhm.
So it would have to intersect like right here in the middle of this edge, right?
Mhm. And that should be the halfway point.
Yeah. And all it says is to describe the shortest path and justify your answer. So we're just generally describing it. So I don't know if we need to find out exactly numerically what it is. Right?
I'm thinking no.
Okay.
I'm hoping no.
Okay. So how do we want to describe this path?
Can we describe it as the net, the shortest distance, like she said, the shortest distance between 2 points
Is a straight line.
is a straight line on the net?
So it's like going like this.
Mm-hmm.
That's the straight line. Between A and B.
Okay, as y'all are wrapping up, make sure that you can
Okay.
justify your answer, and we will have each group come up and explain. So you'll be with your group, and then you'll explain your answer to the other groups. And then remember, is it unique?
Well, I can only see one straight line distance between those 2 points. on
Yeah,
my drawing,
I
so
would
I'm
say
saying
it's
yes.
unique. That's
Yes.
good.
Yes.
Yeah, these are fast. It said the shortest. It said no. No. What is the shortest?
All right, group one, y'all are up.
Is that nice?
Yes, that's me.
Okay, who wants to present?
Do I have to stand up?
That would be great.
So we were picturing it as a net, if you were to unfold it. And then the shortest distance is the distance between 2 points. I mean, this is a line. The shortest distance between 2 points is a line.
Show them the picture.
Oh.
Okay.
So when you
Okay,
flatten it
awesome.
out, you can make the straight line between A and B that you can't really see when it's.
Awesome.
And then it's
Cute.
unique. I mean,
Yes.
it's unique
Okay, I have a
because
question
there's
about
no-
the unique though.
Okay.
Is the way you drew the net the only way you can draw a net?
Well, that's the thing, because when I drew it, I originally had my A up here,
Mm-hmm.
because I unfolded my cube like this, whereas you
And then
guys
would
went
it
like
be unique
this.
then?
But I think it depends, because if A and B are fixed points, it would be unique. If any of those points could be A and B, then it wouldn't be unique.
This is hard to think about, to be honest, because when I think about it, I think about the 3D picture. I think, okay, this way I'm coming towards the front.
Mhm.
Is there any other way you could?
But that's where if you go the other
From A
way, it's
to
like
B.
you go
Oh,
behind.
you could do the back of it.
But then
It just has to do with how it's, how you undo the cube, kind of.
Yeah.
So there's only
Mhm.
one way depending on which way you view.
Is there?
But would
I
going
think
around the
there
back
has
be
to-
longer though?
I thought so. Because you have to go with the underside.
But it shouldn't be, because it's still the same 2 points.
It's
And
just
it's
that
a
if I go
cube.
in the back, I'm going from here to here instead of here to here.
No. You're still using the same 2 points.
Oh,
No, no, no,
because
no,
you
no.
would go here
Yes.
to there. This, and then the diagonal of that, so it's not unique. No, wait, that path is not unique,
Yeah.
but
I don't think either path is unique. Because picture, like, basically it almost flip-flops. So this one goes here, right? And if I looked at the back of it, I would start at this one and go up to A.
So it'd still be the same
I
length,
It
folded,
would
yeah,
still be the
the A
same.
would be here.
just a different
and then you
route.
would go down. It's still the same, it's still, 2 by 1
Mm-hmm.
Right triangle.
or
Mm-hmm.
triangle
So maybe not unique
Yeah.
path, but it would still be the same length.
length,
Mm.
yeah.
All right, great job. That's good. All right, great job on working together in your groups today. This is how this class is gonna be formatted. So working together is an essential part of this class, and learning math. You're gonna make some connections between math you already know and math you're learning. So hope y'all are excited and ready for a fun year.